Hello students, welcome back. Let us continue with sample paper 1, question number 27 of section D. So it states that a cuboidal box each has edge 10 centimeters and there is another cuboidal box which has dimensions 12.5 centimeters into 10 centimeters into 8 centimeters. So this means nothing but length, breadth and height, or length, width and height. Now we need to find out two things. One, which of these boxes has a greater lateral surface area and by how much, and the other one, which box has the smaller total surface area and by how much. So let's see, first of all, what do we have? We have a cube and we have a cuboidal box. So what's the difference between a cube and cuboidal box? Well, the similarity is that they both are boxes, but in a cube we know that it is made up of square edges. So all the edges are going to be equal in length. So each of these sides are equal to each other, which is 10 centimeter as given. And what about a cuboidal box? A cuboidal box again is a box as the name suggests, but it is rectangular and has 3 dimensions, which is nothing but length, breadth and height, or length, width and height. So this base is the length. So will this be the length? This is the length and this is the length. So four edges are equal in length. Then you have breadth or width denoted by B, and this is height. So when we are talking about lateral surface area we're considering only the 4 walls. We are not considering the roof and the base because they are not lateral. Lateral means side. So side over here would be the edges, right? So for a square, we have learned that it is going to be 4 into side square, whereas for a cuboidal box, it would be twice breadth into height and twice length into height, because you have 2 faces of the same area, right? 2 of the length and breadth, 2 of the breadth and height, and 2 of the length and height. So let us first go ahead and find the lateral surface area of both the boxes as well as the total surface area, compare them and write the solutions to these questions. So again, I'm going to start with whatever is given. So given for a cube, I have side is equal to 10 centimeters, whereas for a cuboidal box, so I'll say instead for a cuboid, I have length into breadth into height as 12.5 centimeters into 10 centimeters into 8 centimeters. And to find, just copy the question as it is. I'm not rewriting it. You need to write both these questions. Okay. So I'll say copy statement numbers 1 and 2. So I'll say solution, finding lateral surface area and total surface area of cube. So what is the lateral surface area going to be? It's nothing but the curved surface area, which is going to be 4 into side square, which is 4 into 10 square, which is going to be 4 into 100, which is 400 centimeter square. Because we are talking about the surface area, it is always given as unit square or square units. So this is the lateral surface area. I'm going to mark this statement as 1. Now again, finding the total surface area. So total surface area is going to have, a cube has 6 faces. So the total surface area would be 6 into side square, which would be 4 into 10 square, which is, 6 into 10 square, which is 6 into 100, which is 600 centimeter square. This is the total surface area of your cube. So I'll say lateral surface area 1, total surface area 1. Now what we will do is find the lateral surface area and curved surface area of the cuboid. So let's do this on the other side of the board. So finding lateral surface area and total surface area of cuboid. So lateral surface area is going to be 2 times length into height plus twice breadth into height, because there are two surfaces that are going to have dimensions length into height and two which will have dimensions breadth into height for lateral surface area. So I am going to remove 2h common and L plus B. So substituting these values, I get 2 into height, which is 8. So 2 into 8 and length plus height. So this is 12.5 plus 10. So this is going to be 2 8s are 16 and 12.5 plus 10 is 22.5. So now let's calculate this. Now instead of 22.5, I am just going to write 225 upon 10. In order to get rid of the decimal point here, I have written 225 upon 10, and 16 I will write as 10 plus 6. So this gives me 2250 divided by 10 plus 6 into 225 divided by 10. So what I am doing is following the distributive law, wherein I am multiplying this term, this entire term of fraction, with these two terms with a plus sign in between. So let's calculate. 6 5s are 30, 6 2s are 12, 13 14 15, 6 2s are 12, 13 upon 10. So 0 and 0, 0 and 0. So now what we are left with is 225 plus 135. So 225 plus 135 gives me 6 and 360. So the lateral surface area is 360 centimeters square, and this is the lateral surface area of our cuboid. I am going to mark this as 3. So lateral surface area 2, because we have lateral surface area 1 over here for the cube. Now what we are going to do is find the total surface area of the cuboid. So total surface area is going to be twice length into breadth plus breadth into height plus length into height, because there are two faces each having dimension length breadth, breadth height and length height, right? Because there are 6 surfaces, so 2 plus 2 and 2, 6 faces for a cuboid. So this is going to be 2, length is 12.5, so 12.5, and breadth is 10 plus breadth into height, so 10 into 8 plus length into height, which is 12.5 into 8. So now we are going to follow the rules of BODMAS and solve this entire expression. You get 2 125 plus 10 into 8, which is 80, plus 12.5 into 8. So 8 5s are 40 and 8 1s are 8, 8 2s are 16 plus 4 20, 8 1s are 8, 9 10. So now you have to first solve this bracket inside, that is you are going to add up these terms. So 125 plus 100 is 225, and 225 plus 80 gives me 503. So this is 2 into 305, which is going to be 2 5s are 10 and 2 3s are 6, 610 centimeters square. This is the total surface area 2 of your cuboid. And I am going to mark this as 4. So now what do we need to compare? We need to compare equations number 1 and 3 and 2 and 4, because we need to compare the lateral surface area and total surface area of the cube and cuboid. So now comparing 1 and 3, what do you get? You get that the lateral surface area of the cube is more as compared to that of the cuboid, and comparing 2 and 4, I get that the total surface area of the cuboid is more. Now here comparing 1 and 3 back again, by how much is the lateral surface area more? By the you will take the difference of 400 and 360, that is 400 minus 360, which is 40. Similarly, the total surface area of the cuboid is more compared to that of the cube by taking the difference of 610, which is the greater number, minus 600, which is going to give you 10. So the total surface area of the cuboid is more than the total surface area of the cube by 10 centimeters square. So let's write this down. You will just say answer 1. Lateral surface area of cube is more than the cuboid by 40 centimeters square, and then you will say comparing 1 and 3. And your second answer, total surface area of cuboid is more than the cube by 10 centimeters square. And here you will say comparing equation numbers 2 and 4. So here is the solution to question number 27. We'll take a look at the second question, that's 28, in the next class. Please take a look. Thank you for watching this video.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.